Hello and welcome. My name is Sebastian Hörl from IRT SystemX, and I want to briefly introduce in this video what is a digital twin and how is it used in logistics and in planning in the context of the project lead. So just to give a short overview of this section, first we want to look at definitions and give a definition of a digital twin in our lead project. Then we can have a look at different use cases of this digital twin and later look at some key elements that make up digital twin architectures. To talk about the definition, one has to say that there are various definitions that exist and they strongly depend on the application domain. So there are many digital twins also in manufacturing or in vehicle control on the vehicle level. But basically the common idea is that we have a representation of real physical assets, their behavior and also their interactions in a computer-based digital model. So this means that we take things that exist in reality. These can be very technical things and systems, but also social systems, whole urban systems, and we try to represent them in digital models. And the definitions that we will use here, they are based on two publications by Wildfire and Betty, who focus on digital twins in the urban context. In these publications, we have different perspectives on digital twins, and they make the difference between predictive and reactive digital twins. Predictive digital twins are seen as representations of reality as models that work on the long term. So they model developments over months and years. So there's long time scales. These models are usually very complex and also interconnected. Often we have setups of multiple models which influence each other. So there we have a very detailed modeling of a system, such as a city, which allows to answer quite detailed questions about the system. An example, for instance, is setting up a whole new transport infrastructure in a city, like adding new lanes, adding new mobility hubs, and then exploring how these new additions to the city work together, and also how are they used by the population, for instance. On the other hand, there are reactive digital twins. They work on a very short time scale, almost real time in many cases. This means that they need to be relatively simple so they can be run on a very quick time scale. So they also have a high level of abstraction and they look at a very specific use case. So an example here could be that we only look at a specific train station. We know which trains will arrive in the future. We know how many passengers maybe arrive in this train station. So we can estimate the flows of passengers and also of vehicles in these train stations, maybe for the next couple of minutes. Now these were examples for the transport system in general. Let's pass on to some examples or to the perspective from logistics. So in logistics, we also can have predictive digital twins and reactive digital twins. For the predictive case, we have many use cases on the whole urban system that we look at in the LEAD project and in these digital twins for urban logistics in general. So there we can have concepts such as urban consolidation centers, where a new central spot is installed in a certain neighborhood in a city, and then all flows of goods, of parcels and so on arriving in this neighborhood must pass through this urban consolidation center, and then all of this is distributed on the finer level, on the last mile, with emission-free vehicles, for instance. And there we have a lot of components that work together and which need to be modeled in a very complex interaction. This is the same for policies. If we say that we implement new policies, for instance, who and when can enter the city and what they can do at certain times in the city, then this has effects not only on the very specific last mile deliveries, but also on the whole supply chain and maybe even on all the other participants in the transport system. So for instance, also passenger transport. So again, a very complex example of a digital twin, and this is where we can use a predictive digital twin to develop new scenarios and explore how the future will look like if we apply certain concepts. So in general here the goal is to assess the combined impact of technologies, new services and also new policies. On the other hand, in urban logistics we can have reactive digital twins. There are many closed loop use cases where we even have the physical asset on one side, then we have the digital model that we can use to find new inputs to the system and then change the system in a closed loop fashion so that we can, for instance, optimize certain services. And there we have quite many examples on the small time scale. So for instance, we can model the arrivals in a logistics center and then respond to them by having enough of staff available, for instance, when a new truck arrives, or even on the routing level of the vehicles. If we have a model that gives us the congestion in the city at a certain time, we can reroute the vehicles to avoid this congestion. So in general here the goal is always, or most of the times, to increase the quality of a service and also its efficiency. So what are general elements if we look in the general setup of a digital twin for urban logistics? The first component are physical assets. As already mentioned, this can be vehicles, this can be a distribution center, this can be containers, this can be individual goods. So these are basically the elements that are in the real world and that we have available to understand the system. On the other hand, we have all the stakeholders that are interested in making the system more efficient, in making a city more livable, for instance, in taxing services, in making their services as increasing the quality of their services. So these are all the stakeholders which may be interested in estimating, knowing certain things about the system, and maybe even giving certain inputs to the system to bring it to a new state where things work more smoothly, where things are more equitable, and so on. And between these we have the digital twin. And in this digital twin we have two individual components. On one side we have the interface to the physical world. So there we have concepts from the Internet of Things. So we have a lot of gadgets that are connected to a server that send continuously information, but which may also receive information. And one of the challenges is here is to make this as generic as possible. So we also need a data model which basically shows us what data is available, what data do we need maybe, and how can we estimate or obtain this data from the whole infrastructure that we have, and also how can we send inputs to this infrastructure. So there's basically this connecting part that is turning all around the data and also stores this data on the physical assets. Now with this data we want to do something, and for this we have the modeling and the simulation component. So inside of this digital twin we receive data from reality. We then use this data to refine our models, to run simulations, to find future states of the system, and then based on these outputs we can, for instance, generate new systems for the real new inputs for the real system, and update in general what we want to do in our logistics environment. And of course we can inform all the stakeholders that we see on the right. They can now also influence the scenarios that are generated by our digital twin, that are proposed by our digital twin, and also just use information that have been estimated from the system. And In the coming sections, and already in the sections that you saw in this online course, you will see how all of these components work together to improve the urban logistics system in the project lead. So with this, I hope you have a general overview what is a digital twin in logistics, and feel free to contact us if you have any questions on the subject. Thank you.